When we talk about Kubernetes, a few big names always seem to get the spotlight. But there's this quiet, unsung hero working behind the scenes, a tireless supervisor that just makes sure everything works. Today, we're going to pull back that curtain and give this crucial component the attention it deserves.
So imagine you say this to your cluster. It's a simple, clear statement of what you want. You've declared your intent. But who's actually listening? And more importantly, who's going to enforce that rule 24/7, even when a server crashes at 3 in the morning? Who makes sure your wish stays a reality, no matter what? Well, let's find out.
So here's our game plan. We'll start with this idea of a never-sleeping supervisor. Then we'll meet the specialized team of controllers that are doing all the work. We're going to see them in an action-packed example, uncover the magic reconciliation loop that powers them all, and finally get why this thing is basically the autocorrect for your entire cluster.
All right, first up, the never-sleeping supervisor. To really get this, just picture your Kubernetes cluster as a massive automated car factory. You've got robots welding, machines painting, the whole shebang. But you absolutely need someone or something constantly walking the factory floor, making sure every single part of that line is running exactly the way you designed it. And that is the Kube Controller Manager. Its entire reason for existing, its one and only job, is to be in a constant tug-of-war between two things: the current state, what's actually happening in your cluster right now, and the desired state, what you wrote down in your YAML files. And its job is to make sure your desired state always wins.
Think of it like this. You just write your goal on a whiteboard and you can walk away. The controller manager is that supervisor who never sleeps, never takes a coffee break. It sees a server crash dropping your count to 4. Bam! It immediately spins up a new one. It sees someone accidentally added a 6th one. Nope! It terminates the extra. It is a relentless, tireless enforcer of your rules.
But here's the really clever part. This isn't just one supervisor trying to do everything at once. I mean, that would be total chaos. Instead, the controller manager is actually a highly specialized crew where each member is an absolute expert at their one specific job.
So if you look under the hood, the Kube Controller Manager is just a single program, one process. But what's so cool is that running inside that one process is a whole collection of these individual, smaller controllers. Each one is laser-focused on managing just one specific type of Kubernetes resource.
And this division of labor is absolutely key. For instance, you've got the replica set controller. Its only job is to make sure you have the right number of pods. That's all it cares about. Then there's the node controller, which does nothing but watch for unhealthy nodes. The deployment controller, it just focuses on managing your rollouts. Each one is an expert, staying in its lane, constantly watching its own little corner of the cluster.
Okay, theory is great and all, but let's actually see this team in action. We're going to walk through step by step what really happens when you go to deploy a simple application.
All right, you're at your terminal, you run kubectl apply. The instant you hit enter, the deployment controller sees your new deployment object. Its first job? To create a matching replica set. The very moment that replica set exists, the replica set controller sees it, notices you want 3 pods but currently have 0, and it just springs into action creating them. It's a perfect automated handoff. And this is where you see that self-healing power shine. Say someone deletes a pod by accident. Before they can even say, oops, the replica set controller has already noticed the mismatch. Hey, I see 2, but I want 3. And it's creating a replacement. Or if you scale your deployment up to 10, the deployment controller just updates the replica set's desired count, and the replica set controller dutifully gets to work creating those 7 new pods. It's just constant, automatic correction.
So we've seen what it does, but how does it do it? What's the core logic, the secret sauce that powers every single one of these controllers? Well, it's actually surprisingly simple.
It all comes down to this, a simple, infinite loop. Every controller is constantly watching the cluster's current state. Then, it compares that to the desired state you want. If there's any difference at all, it acts to fix it. And then, it repeats that cycle, over and over, forever. Watch, compare, act. That is the heartbeat of Kubernetes. And this powerful watch, compare, act process, it has a name. It's called the reconciliation loop. This isn't just some trick for the controller manager. This loop is the fundamental operating principle of Kubernetes itself. It's the very engine of all its automation.
This reconciliation loop is exactly why you always hear people call Kubernetes a declarative system. You're not giving it a list of step-by-step commands. You're not saying, first create pod 1, then create pod 2. No,
You just declare the end state you want, like, I want 3 Nginx pods, and you trust the controllers and their infinite loops to figure out how to make that a reality.
So, we've established it's important. But just how important are we talking? What would actually happen if this supervisor just went offline?
Let's just ask the question directly. If this central brain of your cluster stops working, what are the immediate consequences? What breaks?
The fallout is immediate, and it is severe. If a pod crashes, it stays crashed. Any scaling commands you run will do absolutely nothing. If a physical node dies, the cluster won't even notice, leaving all its workloads just stuck in limbo. All of a sudden, the entire automated, self-healing magic of Kubernetes is just gone. It becomes a static, fragile system that you have to babysit all the time.
Now, because it's so critical, Kubernetes goes to great lengths to protect it. It runs on the control plane nodes, and in a high availability setup, a process called leader election makes sure that even though you might have multiple copies running, only one is the active leader at any given time. This prevents them from fighting, and if that leader fails, another one takes over in seconds.
So after all of that, what's the single best way to remember what the controller manager does? Well, it really comes down to one simple idea.
That's it, right there. It's the autocorrect feature for your entire infrastructure. You state what you want, and if reality ever drifts from that because of a hardware failure, a typo, whatever, the controller manager instantly and automatically corrects it back to what you intended.
Though, to wrap up, just remember these 3 things. 1. The controller manager is a team of tireless specialists. 2. Their entire job is that simple, powerful loop. Look at what the human wanted, look at what actually exists, and fix any difference. And 3, that loop is the absolute core of Kubernetes' self-healing magic. And that leaves us with one final, really fascinating thought. If this autocorrect pattern is so powerful for built-in stuff, what happens when you start applying it to your own applications? What happens when you teach Kubernetes how to autocorrect your custom software? Well, that's the world of custom controllers and operators, and that's where the true power of Kubernetes really begins.